Six. Oke, Bismillah. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Okay, praise to God and peace be upon Him, Muhammad sallallahu alaihi wasallam. My name is Azhar Ahdian. Today we are going to talk about greenhouse gas emissions exposures mapping using quantum GIS and ALOHA software. Welcome to this class. I would like to share my screens. Share. Okay. Okay. Before we talk about greenhouse gases emissions, we have to know the reasons why we talk about these topics. Sorry. Okay. Okay. The reason why we talk about these topics is because we are now facing the global increased temperature, or we know as global warming. And the global warmings has been occurred since 200 last, since the foundations, or when the James Watt found the steam engines on 1776, and until now the global temperature is always increasing by 2 Celsius degree, and it might result the increasing number of the air conditioning units, and as we know that the increasing number of air conditioning units might increase the heat emissions to the atmospheres, that may increase the more global temperature. Okay, we have to understand the definitions of the greenhouse gases. Before we talk about the greenhouse gases, we have to talk about the greenhouse itself. As we know that greenhouse was found by Roman Empire on 30 Anno Domino 30 AD, and greenhouse is a structure with walls and roof made of glass. It is designed to trap solar heat radiations during the day, so that interior remains warm at night. So when we enter to the greenhouse, we feel warmer. Yes, usually the farmers in the winter use the greenhouse to make their plants still grow, and to make their agricultures still grow, and and the temperature countries may enable to continuous cultivations. Okay, sorry, to mute the speakers. Okay, and the greenhouse effects today refers to similar phenomenon occurring on our Earth's atmospheres, where solar heat becomes trapped. It leads to rise the global temperatures. So the global increasing temperatures is caused by the solar heat trapped by greenhouse gas emissions. Okay. This is the mechanisms how the greenhouse gases trap the solar radiations. Yeah, as we know, the solar radiations that enter to our atmospheres are absorbed by Earth's surface. Yes, there are so many kinds of land covers. There are many types of land covers, such as forest, settlements, water body, and many others of land covers. Some land covers might absorb and process the solar radiations, like forest and agriculture land covers, yeah, with the photosynthesis process, but some others re-radiated the infrared radiations. And the infrared radiations enter to the atmospheres and absorbed by some greenhouse gases. Yes. And the greenhouse gases re-emit the solar radiations, yeah, the infrared radiations, and it makes the uh, our Earth becomes warmer than before. Yes. So the functions of GHG is to make our Earth becomes warmer, but today the GHG emissions is too much. Yes. So it will make the Earth temperature becomes warmer because so many greenhouse gas emissions absorb and then re-emit, so it will make our Earth becomes warmer. And the other side, the land cover change from the vegetations to non-vegetations becomes increasing. Yeah, we know there are so many deforestations and the forest degradations and many other. So it decrease the potentials of the solar radiation to be absorbed. So there are so many solar radiations or infrared re-emit to the atmospheres due to the lack or the decreasing of the vegetations. Okay, so the global warming is caused by two causes. The first is land cover change from the vegetations to non-vegetations. Second is too much greenhouse gases emissions on our atmospheres. Okay. Greenhouse gas emissions is caused by some sectors from energy supply, industry, and agriculture and forestry, transport and buildings. And the most emitted sector is from energy supply because usually energy supply use fossil fuels to support the energy, and it also burns many carbons and emits many carbon to the atmospheres. And second is from industries, and the interesting one is from agriculture, forestry, and land use. Why from these sectors emit so many gas emissions? Because there is a land use, yes, land use change. Land use change may emit carbon dioxide and also methane to the atmospheres. Yes, okay, because of the decompositions of the carbon dioxide. Yes, we understand carbon stocks are usually we call as carbon, not carbon dioxide. Yes, because carbon dioxide is usually for carbon emissions. Yes, uh, we know that the vegetations stores so many carbon. And when the vegetations is changed to non-vegetations, there will be the interactions between the carbon with the with O2 or oxygens. So it will be the carbon emissions, or we call it as carbon CO2, yeah, carbon dioxide. Okay. So from agriculture, forest and use, uh, it will be the emissions, and it gives the one of the factor of the global emissions. Okay, what are greenhouse gases? There are so many greenhouse gases here, but the greatest amount is from carbon dioxide, and second is from methane. Okay, why from carbon dioxide? Because carbon dioxide is resulted by our activity. According to MIT, in 1 year, uh, there are 351 million carbon dioxide circulating in our Earth. But the problem is when the carbon emissions is higher than the carbon sequestrations. Yes, so it will problems. Okay, 90% of the greenhouse gas emissions on our atmosphere is carbon dioxide. So it is dominated with carbon dioxide. So we know about the carbon trading, yes. Why it is not about the methane trading or uh, hydrogen trading, yeah, because carbon is the greatest amount, and it is dominated greenhouse gas emissions. Usually, we know about the term of carbon equivalence. Yes, carbon equivalence is by adding this carbon dioxide and other greenhouse gases. Yeah, for example, when we emit 1 grams of methane, uh, it is equal with 21 gram of carbon dioxide. So if we emit 1 gram, it
There is
equals
no other
with
greenhouse
21
gases
grams
with these
of carbon
gases.
dioxide. So if we emit 2, 3, yeah, we just times it with 21. Okay. Okay. Now, first is carbon dioxide. What is the characteristics of carbon dioxide? Yeah. So the carbon dioxide is a chemical compound consisting of 2 oxygen atoms covalently bonded to a single carbon atom. Okay, so the carbon dioxide is colorless, odorless, and non-flammable gases because the conditions of the melting point and freezing point of the carbon dioxide is high. Yes, it is approximately 3,000 Celsius degree for the melting point of the carbon dioxide. So we cannot see directly the carbon dioxide. Okay, and carbon dioxide is naturally a byproduct from our respirations process. Now we are breathing, we release the carbon dioxide from our breath. Okay, uh, it is not only from us, but also from animals, plants, and other microorganisms from the respiration process that emits the carbon dioxide. Besides that, uh, there are so many activities that emits the carbon dioxide. Okay, if the carbon dioxide is inhaled excessively, it will cause several problems, such as acidosis, nausea, vomiting, seizures, and even death. Okay. Next is methane. Methane is a simple hydrocarbon gas. Usually, it is resulted by agricultural sectors. Okay, and also, it is also resulted by electricity generations, diesel fuels, and other components in fertilizers production. Usually, it is resulted from fertilizer productions. Okay. Next is nitrogen dioxide. Usually, nitrogen dioxide may result the acid rain. Yes, we know it's about the acid rain. Acid rain is when the precipitations, the rain, uh, may change the pH of the soil. Yes, the soil pH ideally for agriculture is about 5.5 to 7.5, but because of the nitrogen dioxide emissions, it will lower the pH, and it will make the soil not suitable to support agricultures. Yes, so it will decrease the productivity of the agricultural sector. And the other hands, the other effects is harmful pollutant that can degrade the environment, damage infrastructures, and uh, alter soil acidity levels. Okay. Next is freon. Yes, it is resulted usually by our air conditioning. Yes, and also from the refrigerators. Yes, so when we use more uh, air conditionings, it will it might cause the increase of the freon gases. Okay. Okay. If you have any questions, feel free to ask before we continue to hands-on practice. Okay, we'll read the chat.
Are there no other greenhouse gases beside this gas?
Okay. Uh, Usually, based on the IPCC, there are 6 greenhouse gases. Yes. Greenhouse gases emissions. It has been mentioned here.
Okay.
Okay, sir. So, okay. For carbon credits, okay, it is about the carbon tradings. Yes. Usually, if we talk about the carbon tradings, it is about to measure the ability of the forest to reduce the carbon emissions. For instance, our forest, we have a forest, and our forest and we have the emissions. Yeah, for instance, I would like to okay to count it. Our emission, for example, is for the first time is 10,000 carbon dioxide. Yes, but with the carbon credit for the project, our emissions after projects becomes 5,000 carbon dioxide. So the value of the carbon to be paid, yes, or carbon credit will 5,000, yes, 5,000 carbon dioxide to be paid, yes. So we don't measure it one 10,000, yes, but we just measure the ability to increase the carbon dioxide, and it will be times maybe with the dollars. For instance, per ton is $3 or $5, yeah, maybe. But if $3, so the price for carbon decreasing is 15,000 dollars. Yes, it is illustrations of the carbon trading. There are so many mechanisms, cap and trade, yes, crediting, and many other mechanisms. Okay, the certificate will be provided after this training. Okay. Okay, next we will begin to measure the GHG exposure using the ALOHA software. Okay. First, we have to install. We have to install the Quantum GIS first. Yes, because we are now using 2 softwares, Quantum GIS and ALOHA. Okay. If you have installed the Quantum GIS, you may open, please type Quantum GIS desktop 3.38.0, and it has been opened. So this is the illustrations of the results of the ALOHA software for greenhouse gas emission, greenhouse gas exposure. So now we just measure or map the greenhouse gas exposure. Okay. Okay. This is the final result. So how to create this? We have to use the ALOHA software. Okay. And the final results, we may also count the area, yes, as area of the threat zone. the orange, red, and red, orange, yellow, and red zone. Yes, it will be three kinds of threat zones. AEGL1, AEGL2, and 3. Yes. AEGL1 signifies the threshold for notable discomfort. Yes, this is the explanations. Okay, the most the most dangerous is AEGL3. Yeah, that represents the threshold for life-threatening effects or might cause death. Yeah. So okay, this is the red zone one. Yes, the red zone. Okay. Okay. I will create a new projects. Okay. Okay. Then we have to open ALOHA software. Okay, this is the result in ALOHA. I would like to create a new. Okay. The first, we have to determine the locations. Yes, the site locations for these projects. Okay. So ALOHA software is software from APA. This software is for mapping. Yeah, this is the functions of the software: scan model, the toxic gas clouds, flammable gas clouds, and many others. Yes, you may download from this URL. Okay, this is for Windows. This is for Mac. Okay. 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 The first step, we have to click the site data to input our locations. Okay. These locations are in US, but today we are not in US. Yeah, we may select the locations, for example, in Indonesia. Okay, we might click add here. Okay, what must we input? We may input the latitude and also the longitude. Yes. Now, how to input? We have to use quantum GIS to determine our location. Okay. Usually, I use the best maps from HCMG GIS. Okay. To install the HCMG GIS, we may click plugins, manage and install plugins. Then we click HMG GIS. Then we click install. Okay. After finishing installation the plugins, we may click best maps. For instance, we click Google Maps to determine our locations. In Indonesia, usually for the industrial locations is near Jakarta, usually in Karawang or Bekasi. Yes, we may click here. Actually, in reality, to do this practice, we have to go to field and collect the data from the field. Okay. There are so many industries and in Cikarang and Bekasi. Okay. And usually I use Google Satellite to determine the industry. Okay. Usually industries
Please, something go
Yes.
back. Some state go back. Some step go back, please.
Oh, yes. Okay.
Which option did you put the map? Please again. Continue again,
Okay.
please.
Okay. Sorry, what is your questions? Okay. I would like to find the industries. For example, we put a point here. Usually, the industry is located here. Okay. Yeah. Okay, we put the new shape file. Yes. What is the function of shape file? To add the point for the industries. Okay. Okay, click here. We just put one point. Yes. For example, here, yes. But in the reality, we have to go to the field to decide what kind of industries of here. Yes, because we have to understand about we have to collect the data about the uh, emissions from the field. Because there is not about the emission itself, but we need also the wind data. Okay, click here. Click OK. Yeah. Okay. Click.
Halo,
Hello.
on kok.
Hello.
Halo, ya.
Hello.
Anh khá gì vậy?
Okay.
Mau đây là đủ diagram kamu.
Click open attribute table. Okay. What is the functions of the attribute table? We have to
Then,
input this,
can I
yes,
get recording
latitude
of this
and
file?
longitude. Okay.
Please provide the recording.
Okay. We will provide the recording.
Okay, thank you.
Yes. With the pleasures. Okay. Okay. We have to add the new field x with the decimal number. Yes. Why decimal number? Because this coordinate reference system is in VGS x, and then we input y. Okay. Open field calculator, application field. Y. 30 Y. Okay. Then we save it. Sorry. Okay. Okay, we have to input the latitude and also the longitude. Yes. But we have to convert it, yes, because this is decimal degree. We have to convert to degree minutes. Okay. Okay. X. Okay, decimal degree. We may use this website. Calculate. Okay, oh, the point. Okay. For the latitude, yes. Longitude, and then next is for the latitude. Okay. Calculate. Okay. This is the results. Then we copy this to the ALOHA. Okay. Okay, the positions, Indonesia position is in south latitude and longitude is in east. Yes. Okay. The latitude is south, this is minus. So we just put 6 without minus. Why? Because we have to click this south. Okay. Sorry, I mean minus 5.8. Okay. Next is longitude and okay, this location is not in US and it's about location Indonesia. Sorry, the industry. Elevations, yeah, usually elevation okay, 11 meters because our position is near with the sea. Okay, have to input it 11 meters. Okay, then we click OK. Country name Indonesia. Okay, and then we have to input the local standard time or GMT. Okay, for the Eastern Hemispheres, we have to input a negative offset -7. Okay, why -7? Because based on the software, for the Eastern Hemisphere, we may input a negative. Yes. Okay. Then we select this. Okay. Building type. Okay, it is based on the building types or single or double story enclosed. Yeah. Okay. This building type is single story building, and we have to decide is there any shelters. Okay. So there's surroundings like or unsheltered. Okay. Okay, we will give the recording. Okay. Okay, click OK. Okay, so shelter surroundings, yes, because the surroundings is usually covered by tree. Click OK. And choose the date and time. We use the internal clock. So the data describe the GHG exposure today. Yes. Okay. Click OK. Set up. Click chemicals. There are so many chemicals, compounds here. Yes. So we choose sulfur dioxide for the examples. Sulfur dioxide. Okay, then we select it. But if there is no gas emissions or your emissions compounds, you may click solutions to enter your you may click add to enter your compounds. Yes, to enter your own chemical names. If there is no gas that you would like to analyze. Okay. Okay, I click sulfur dioxide, select. Okay. Then click atmospheric. Okay, we have to input the wind speed. Wind speed is usually found by Googling. Okay, this is about 3 kilometer per hour, and we have to convert it to mph. 3 kilometer per hour to mph is okay. Mile per hour 1.x6. Okay, when is from? Usually in Indonesia during the dry season, the wind comes from southeast. Yes, we may fill it with southeast. The maximum height above ground is none. So it is based on our field data. Okay. Okay. For today, we just click here. Yes. And ground loudness. Okay. It is felt by the conditions surrounding the area. We may choose urban or forest. Yes, because there is still forest here. Okay. Then we may click OK. Okay. Okay. So sorry. Then select the cloud covers. How about the cloud covers today? Okay. This is mostly sunny.
Wọ́n lọ school náà tẹ́ wà time conscious nípa
Okay.
ìyẹn time báyìí mo jí o
So
time báyìí
it will
time
be
báyìí mo jí láti ṣe nǹkan tó
clear.
fẹ́ ṣe tẹ́ẹ̀jọ mọ̀ wá tẹ́sítà.
Sorry. Click OK. Okay. Then select the humidity. The humidity is 51%. Then click OK. Okay. Then, select the air temperature. Yes, we have to input air temperature is 33 Celsius. Okay. Okay. And click OK. And source, we may click direct source. So the source of emissions is various. You may click paddle if it is from the paddles or from the pipelines and many others. But for this example, we click direct emissions. Okay. For these examples, we click kilograms. Yes. Okay. For example, this emissions is 1 kilograms per minute. Okay. Okay. Enter source of heat. Yes. So usually from industry is not from the source. Yes. Usually it comes from the air or okay. For examples, the source maybe comes from 10 meters. Yes. Okay. We have to measure where is the source of the uh, emissions. Yes. Usually from industry, is not from ground. Okay. We click 10 meters. Click OK. Click OK. Then we click trade zone. Okay. This is the local trade zone. I have explained what is the definitions of AEGLs, AEGL2, and others. Okay. Here if you have the literature, you may add by your reference. Yes. But today I use the literature from ALOHA. Yes. Okay. Okay. Then we click wind directions. So the exposure is influenced by wind directions. Okay. Okay. We click OK. Okay. So this is the results of the GHG exposure. Sulfur dioxide exposure. Then we have to click File and Export Treat Zones. Yeah, we will export it to KML format. And then we open on our Quantum GIS. Okay. About the point is, okay. And we copy it. And for magnitude, okay. Then we fill it south and it is east. Okay, 5. But 49.2. Yes. Five. 58 and next. Okay. This is on south and east. Yes. Because our location is under the equator, south and east. Then we click OK. The results. Exposure. We click here, add vector layer. as sulfur dioxide exposure. Then we add layers. Okay, this is our area. Yes. Okay.
अमिया गल बना
Okay.
के लेके बंदा दस रही है आ कपड़ा के
Sorry to mute the speakers. Okay. Any questions until this process?
No,
Hello?
no questions. It is clear.
Okay, okay, sir. Okay. Okay. This is the exposures, the threat zones, and we may count the area of these exposures. Okay. Okay. It is still in VGS format. Usually to count the area, we have to change to UTM format. Yes. Okay, the UTM format is UTM zone 48. Click here. Okay. UTM zone 48. How do we know it? Yes, we may find an UTM zone Indonesia. We click, yeah, just look, our location is here. So we click UTM zone 48. Okay, then click the file name, click thread zones, click OK. Okay, click open input table. Here field area. Then we have to click OK. Okay, then open field calculator, update existing field, and click area, dollars area. Okay, it's in metal areas. Click OK. Okay. So the red region is 2000 2.5 thousand meters, and the orange 86,000, yes, and the yellow is 300,000 more. Okay. Click properties, symbology, and you categorized. We click name, classify. Okay, maybe the wind is not included. We just include the orange zone. Red zone, it's yellow. Okay. Okay, this is our threat zone. Yes, it is influenced or affected by the wind directions because the wind is from southeast, and then our sulfur dioxide exposure is uh, to these directions. Okay. Okay. Right. Okay. And this is our area. Yes. Okay. Fortunately, it is not affected or it is not endanger the households. Yes, because there is no house here. Yes, and there is a urban forest here, and usually the emission is trapped by urban forest. Okay. Okay, the last part is usually we layout it on our GH on our quantum GIS. Click new plan layout. Okay, then we create a simple layouting as map. Your coordinates. Okay. Next, create the angels here. Create title. Hmm. The time was, if I'm not miss it. Hmm. Give me here. Red zone. Orange, wind direction is not included. Okay. After develop layers, we may save it on layout this. Export as image. Okay. This is the results of our map. Okay. Okay. So this is the end of this pre-course. Yes. We have to learn a little bit of GHG emissions and GHG exposure using Quantum GIS and ALOHA software. Okay. Before we close these sessions, feel free to ask any questions related to these topics. Okay, about the certificates, you may ask the admin. Yes, and usually the admin will inform you about the certificates on WhatsApp group. Okay. Okay, with the pleasure, sir. Okay. Any other questions? Okay, the same questions. Certificates. Okay, the certificates and recording will be provided, and the admin will share it on our group, on GS group. Okay.
Hello, sir.
Yes, sir.
Sir, how can we do this type of mapping for a province or for a large city?
Okay. For the large city. Okay. Hello. Okay.
Yes,
For the
yes,
large
sir.
city, we have to maybe we have to input not only one point. Yes, maybe some points. But unfortunately, the software is only processing points by points. So we just input points. If we have finished one point, we create the map from another points, like that, sir. Okay. This example is only for 1 point. Yes. Because we are now mapping the exposures, yes, not about the GHG, not all GHGs, like GHG from Earth engines or other softwares. Yes, just the exposures. Okay.
Okay, sir. Thank you.
Yes, with pleasure, sir. Okay. If there is no questions, before we there is the reductions in GHG. Yes, okay. This mapping procedures is for exposure, sir. Yes. Yes, not about the large of GHG. Sorry, this is for the only exposures, GHG exposures, not GHG amount. Okay. Okay, for okay. Size of point. Usually it depends on the size of your city. Yes. The larger city, the more points. Okay. Usually maybe some of reference state 2% of the total area of a city. Yes. Yes. Or 1% or many other reference. Yes. Based on the literature. Okay. The wind directions. The correlations between the wind directions and GHG exposures, the wind directions might direct the GHG exposure. When the wind directions from here, from southeast, it will direct the GHG to this part. Yes, usually from for example, if the wind is from north, it will direct the GHG to south part. Yes. Okay. 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 Before we close the sessions, please open your camera to the documentation sessions. Okay. Okay, this is the documentation sessions. Okay. Next. Okay. Thank you for attention. If you have any questions, feel free to send your message to my WhatsApp numbers. Yes, I am on the same group. Okay. I would like to close the sessions. Thanks for attention and participations. Certificates and recording will be shared by admin. And for certificate, you have to fill the form that is shared by admin next. Okay, thank you. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon.